Welcome to this XDK2MAM video tutorial for the Bluetooth Low Energy or BLE package. Today, I'll be guiding you step by step through the process of connecting Bosch's XDK110 to a BLE listening device and set up a Node.js server that will retrieve that data and publish it to the Tangle using Masked Authenticated Messaging or MAM. In this case, the device that will be listening via Bluetooth Low Energy will be a Raspberry Pi 3 with Raspbian OS. But you can use any other device with Bluetooth capabilities that accepts Node.js code. So, let's see what we'll be using today. Xdk Workbench. This is an Eclipse-based IDE. If you don't have it installed, you can go to xdk.io. In the Downloads section, find the version that suits your OS. This software is essential to import the code and then flash it to the XDK110. You will also need to have Node.js installed. You can get it by entering nodejs.org and downloading the version that suits your system. If you want to know whether you have Node.js already installed, you can type the command line node -v. If it returns a version number, then it is already installed. The tested and recommended version number of Node.js for this method is version number 8. The Git Command Line is going to be very handy for this method because it won't only help you install the repository, but it will also allow us to use a command line that uses SSH, which is the method we'll use to access the Bluetooth device. As we said, the Raspberry Pi in this case. But of course, you can use other SSH command lines if you prefer so. So to begin, we'll go to the XDK2MAM website and into the section The Code. Here you'll find different solutions to send the sensors data to be published in the Tangle. Today, we'll be using the BLE microSD package. This method uses a microSD card to store the config file. A solution that doesn't require a microSD card will be available soon, but keep in mind that using a microSD card implies more portability, since all settings will be saved onto the microSD that goes in the XDK110. So you can easily modify the config file should you need to. Otherwise, every time you want to change some settings, you'll have to recompile the code and flash it to the XDK110, which is far more cumbersome. Now we'll access the GitHub repository. First, make sure the version number of the package we're about to download matches the Xdk Workbench release number you have installed. Here, I'll copy the repository and go to the command line to do a git clone that will copy everything we'll need to the C drive. When we go to that folder that was just copied, we can see a folder called XDK2MAM that contains the different methods to connect our XDK110, including BLE. Inside that folder, there's a config file. First of all, we have to copy that file onto the microSD card and then open it. Here you can change the device name, which is very useful if you want to easily tell apart your devices when you have several of them working. And you can also modify the request interval. It's expressed in milliseconds here, so the data will be sent every 30 seconds. And here we can choose which of the sensors will be included in the dataset. So once we're done, we save these changes and eject the microSD card. Then plug it contacts up into the XDK110's microSD slot. So the next step is to open the Xdk Workbench, then go to File, Import, General, Projects from Folder or Archive, next Directory, and browse to the folder we just downloaded. Then open the BLE-SDcard folder, XDK2MAM-C, that's the folder we were looking for, so click Accept, then Finish. Now, you have to right-click on the XDK2MAM folder in the Project Explorer panel and select Clean Project. After the cleaning is complete, right-click once again and choose Build Project. This is going to compile the project. Depending on your CPU, this might take several minutes. The compilation process ended correctly. Don't worry if you get some warnings, that's normal as long as it states that the compilation was correct. Now connect the Xdk110 to the computer USB port and then turn the switch to on. Next, we'll be flashing the code by clicking this button. We have to give it some time, and as soon as it finishes flashing, the XDK110 is going to start sending the data. So this is it, the first dataset. But the Bluetooth device is not listening for that data yet. Therefore, this message appears: error in BLE package. Now let's go back to the Git command line. As we said already, this particular command line will help us connect to the Raspberry Pi. First, I have to introduce my Raspberry Pi's IP address on this Wi-Fi network. So I will type SSH space PI at and the Raspberry Pi's IP address. And then we must enter the password for the default Pi user that we defined when installing Raspbian. So we get this pi at Raspberry Pi prompt. Now I'm going to make a directory called tutorial and then access that directory. We have to make sure that Git is installed in our device, in our Raspberry Pi, and Raspberries are usually already pre-installed with Git. If it's not, you can install it by entering sudo apt install git. If it's already installed, it will say so, as in this case. What we have to do next is download again the whole XDK2MAM repository here into the Raspberry Pi. Go back to the GitHub repository, copy that link, and do a git clone of the whole package. One more thing that you should know is that the BLE method is based on Noble, so this node library requires some packages to be installed beforehand that might be different according to the OS of your device. If you go back to the XDK2MAM BLE packages README file, you can find a link to the Noble repo, where you can read what the required dependencies are for your OS. In this case, I'll download the Linux packages. So in our case, we would need to install libbluetooth-dev. So in order to install it, I'm going to copy this command and paste it here in the command line. Once dependencies are installed for your OS, we are ready to continue. So we'll enter into the XDK2MAM folder and then the BLE-SDcard folder. In here, we have a C and a Node.js folder. The first was used when we downloaded the repo to the computer. This time, we need to access the Node.js folder and install all the modules before we can edit the XDK2MAM BLE.js file. So we type npm -i and wait until it installs. It's very important to have Node.js installed in your Raspberry Pi. So again, if you want to know whether you have it already installed, you can type node -v. Keep in mind that the tested and recommended version number of Node.js for this method is version number 8. If Node.js doesn't happen to be installed in your device, you can type sudo apt install node npm. Now let's take a look into the Node.js folder, and we can see a file called xdk2mam-ble.js that we'll have to edit. Since we're at the console, we can't use a graphic IDE, but a console editor. So I will choose to go with Nano, which is one of the most commonly used editors in Debian-based systems. But you could also use other editors like Vi, for example, if you preferred. So we type Nano and the name of the file to be edited. And the first thing we must edit is the full node data. If you don't know which node to use, you can enter iota.dance and choose one of the full nodes available there. Make sure it has proof of work checkmarked. Copy the node and port data. The next thing to be changed is the seed. Remember, the seed must be exactly 81 characters long and must be comprised of uppercase letters A to C or the number 9. So in this example, we'll change the last 5 characters like this. This is your channel identifier, and your data will be on the same channel as long as you use your own seed. For example, the seed that is set by default in the code is meant as a placeholder. If you use it, your data will be published alongside a lot of data that might have already been published using that seed. So now we must save these changes by pressing Ctrl plus the letter O. We are asked whether we want to overwrite the file, so we hit Enter and then press Ctrl plus X in order to exit. And we're back at the console. So now there's just one more thing missing for the Bluetooth device to be able to start listening. We will need to type sudo node xdk2mam-ble.js and then add our device name, in this case XDK tutorial. If you're in doubt about the device name you entered earlier, you can go back to the Workbench console and find it here. When we finally pressed enter, the Raspberry will promptly start receiving the datasets sent by the XDK110 through Bluetooth. And we should get the root number back at any moment. And this is it. If you don't get the root after several datasets have been sent, that probably means that the full node you chose from IOTA.dance is not running correctly. So what you'll have to do is pick a different one and edit it back into the settings using Nano. If you want to make sure your datasets are being published correctly to the Tangle, you can copy this root and enter the tangle.org. Go into Services, MAM Decoder, and paste the root here, then click Decode. So here we can see the datasets are being published to the Tangle. You can see the data sent from our sensor is displayed here in trytes, JSON, and TXT. So we just sent the XDK110 sensor's data to the Tangle using the XDK2MAM Bluetooth Low Energy microSD card package. The datasets are now decentralized and unchangeable. And this is it for today. Thank you for viewing this XDK2MAM video tutorial. For more information and resources, go to xdk2mam.io.